This is the ninth in a series of video-based lessons that will provide you with introduction to stored procedures and triggers and their role in database application development. We will start with discussing the reasons for using stored procedures and triggers in modern database management systems. We will continue by reviewing the basics of PLSQL, the database programming language, and its MySQL flavor. It is assumed that the students have had a basic programming class and are familiar with the introductory programming constructs such as variables, assignment, if then else, looping, procedures, and functions. Then we'll define a stored procedure in general and provide multiple examples of how stored procedures and functions can be used in database applications. The lesson will conclude with an overview of triggers with some basic examples of their use. This material is covered in Chapter 11 in the textbook. In today's modern database application development, the non-procedural SQL access is simply not enough to manage the complexity of user requirements and needs of these systems. Database programming languages, PLs, in general, and stored procedures in particular, provide a number of advantages over trying to do everything through SQL. One of the main advantages of PLs and stored procedures is the code reuse on different platforms and in different situations. Stored procedures also provide an added level of security and faster execution time by being located and executed on a server rather than having SQL code embedded in the user interface. This provides for a three-tiered client-server architecture where the so-called business slash logic slash application slash middle tier resides in between the presentation user interface tier and the data tier, aka database server. This further promotes one of the core tenets of client-server database architecture of separating business application logic on the middle tier from the data on the database server. Triggers are specialized stored procedures that provide rules for processing of some common tasks like insert, update, and delete operations. Unlike stored procedures, triggers are automatically executed in response to certain events and provide a sort of background processing of mundane but necessary tasks, often on a pre-programmed schedule. They're crucial to maintaining the integrity of the database relationships and overall processing efficiency. Stored procedures and triggers, viewed together, allow for an increased level of customization, security, efficiency, and overall performance of database applications. They facilitate event programming in response to user actions and various database operations, allow for more portability of DB applications, and also enable the use of some of the more complex operations such as recursion, not typically supported by non-procedural SQL access. In order to work with stored procedures and triggers, we have to provide a brief overview of database programming languages in general and MySQL's PL/SQL in particular. We're not going to use the standard PLs such as Java, C++, VB, or Python in the context of the database programming, since this is outside the scope of this class, but we will discuss in some level of detail the basics of PLSQL using MySQL's version of the language. At the coding level, a simple definition of a database program is a combination of programming language with non-procedural SQL statements. There are two types of integration of PLs with SQL. One, statement level interface SLI that allows us to embed SQL statements in the host program's code. We've shown a simple example, see slide 18 in 01 Intro DBMS1, showing how MS Access SQL statements can be embedded in VBA code. This example of integration requires changes to host PL syntax to accommodate handling SQL statements. A pre-compiler is used to first compile the SQL statements and then the host's PL code. Also, most of today's DBMSs provide proprietary programming languages that are more tightly integrated with SQL than are the more general PLs such as Java, C++, VB, or Python. The second type of integration of PLs with SQL is the call level interface, CLI, which is an API application interface for embedding SQL into a host PL. There There is a set of dynamically linked libraries, or DLLs, that act as intermediaries between the programming language and a database system. The most widely used CLIs are Microsoft's Open Database Connectivity, ODBC, and Oracle's Java Database Connectivity, JDBC. Both facilitate things like database connection, SQL execution, managing the transfer and processing of the resulting record sets, etc., etc. All this is, again, beyond the scope of an intro DB class. Similar to creating tables and views, a procedure starts with create procedure statement, followed by a procedure name and an optional list of input and output parameters to be discussed in the context of examples to follow. Unless the procedure consists of a single statement, and there are some of those, it must start with the begin and end with the end statement, keywords. Each procedure statement, which does not necessarily correspond to a single line of code, must end with a semicolon. As before, dates are treated as strings until implicitly or explicitly converted to dates. We start by providing a default MySQL date format and hope the implicit conversion takes place. If not, we will use str2date function to explicitly convert a string to a date. As always, be careful when using null keyword and do not assume that a string is empty if not explicitly set as such. Variable declaration is done with a declare statement, followed by variable name, data type, and an optional default value specified by the default keyword. Data types are the same as we encountered with the create table statement. I will tend to use double instead of decimal for expediency and will not always try to match the char or varchar sizes to their table equivalents correctly. You will also see the use of a select statement for quick output, often as simply as a list of variables separated by commas, and sometimes including the explanatory string labels. To run the procedure, especially the one without any input parameters, we will simply use the play button, just like we did for the queries. Other times, we will use the call statement, especially when we want to provide specific input values to be used in the procedure. We will also use simple testing procedures for slightly more complicated examples. The following 5 slides use 6 small SQL files that are either blank, have some code partially or fully completed to go through some of these basics of MySQL's version of PLSQL. We will start by opening MySQL 4_32_ vars declare assign.sql file, which is in lectures sports subfolder of 04 query SQL folder. The code in this file will demonstrate the creation of our first procedure. We will declare several variables of different data types, as shown in the slide, assigning them some values and then displaying them back as results. The drop procedure line of code is a standard way of allowing for multiple attempts to get the procedure's code correct without having to manually drop the procedure every time we discover an error and correct it. Okay, so at this point we'll switch to the MySQL 32 vars declare assignment.sql, and I'm going to try to make it smaller so I can see the code behind it. And we'll start by coding the drop procedure if exists. Okay, ends with a semicolon. Okay, then I'm going to copy the name of the procedure and I'm going to then create procedure, paste it. It must have open close parentheses, and now we don't have a semicolon because this is just the opening of the procedure. Begin statement does not have a semicolon. Typically type a couple of blank lines and then end, and this is the ending semicolon for the entire procedure. Okay, so some of the variables that are declared in this example, okay, are cust full name, okay, as of our char 100. I think the first and last name individually were 50, and again this is the end of the statement, so the semicolon is included. Then I'm going to copy the declare keyword so I can paste it. Fax char 10. Okay, and we're going to show the use of default keyword and then put a string. Make sure to put a semicolon at the end. 555 1 2 3 4 5 6 7. Okay, I'm trying to tab this in, but it's not really necessary. The next line, num orders, integer, default 10, total sales demonstrates the data type decimal, although again I will use mostly double for these types of variables without a default. Then we have order date as date, payment date as date with default, current date, which is essentially a function returning the current date in MySQL. Then we're going to use the set keyword, okay, to make an assignment of customer full name to Jim Smith. So every assignment statement starts with the set keyword. Total sales 2 3 4 dot 5 6. Set order date. We're going to explicitly convert using string to date function a default date format of year first, followed by month and day, and then we're going to use a specific I'm going to confirm that format essentially by using wildcard character Y dash wildcard character M dash wildcard character D. It's a specific format of this function. You can research it by googling, and then we'll output everything using the select statement. Not everything, certain variables. I think it's all of them actually. Cust, fax, num orders, total sales, order date, and payment date. Okay, and I believe that is the end of the procedure. Okay, so I'll make it a little bigger here. In the meantime, I'm going to try to open my Toad. Okay, so we've created a procedure called variables declare assign, right? If we find errors, I'm sure there will be some, we'll run the procedure again, and it's going to be automatically dropped and then recreated. Okay, the beginning and the end mark the beginning and the end of the procedure, and a bunch of variable declarations of different data types: varchar, char, integer, decimal, date, and we had some default assignments and then some explicit assignments with these three set statements, and then we finished by essentially printing all these variables out using the select statement. Okay, so I'm going to go to the sports database and make sure I have the data in it. Let me just typically look at the order detail table. Yep. Okay, and I'm going to switch to the procedures and make sure there are none over there. Okay, and then I'm going to switch to the code. I'm going to copy it. Okay, not including the comments. Doesn't really matter. And then paste it into the editor, and then run it and see if there are any mistakes. Okay, since it seems that there are no mistakes, the procedure is created and it has this little P symbol. Okay, so the simplest way to run it, because it doesn't have any input output parameters or anything like that, is to just use the play button or right click on it and call the procedure. Okay, and it's going to display Jim Smith, all right, customer fax, the default number of orders 10, which was a default, total sales that we explicitly set, order date that we set explicitly, and the payment date, that's just the current date as of this recording, as obviously made on November 18th, 2017. Okay, there is a stamp data type we'll use later on that gives you down to a millisecond or second, whatever. Okay, so I'm going to switch back to the code, make sure it's saved, then back to the presentation, and this is a good place to pause.